Hey everybody, welcome to more integrals of trig functions. This is flipping with Bennett. So we've talked about sine, cosine, and a few other trig functions, but we really left off tangent, cotangent, secant, and cosecant, and there's a reason for that. So I'm going to go ahead today, and when we talk about more trig functions, we're actually talking about tangent, cosecant, things like that. So we're going to go ahead and look at some examples of those and how to integrate them. Okay, so if we look, we're going to find the integral of tangent tan x dx. Okay, so I'm going to go ahead and rewrite the integral. Okay, and what we're going to end up using is u-substitution. So you got to be able to do u-substitution before you do this video. So we know that tangent is equal to sine of x over cosine of x. So just basic definition. Okay, now here's where you're going to see in the next couple problems why we waited and we did these separately in a different video. So let's let u here equal cosine of x. Okay, and that means du equals negative sine x dx. Okay, solving for dx, I get negative du over sine x equals dx. Okay, so now I'm going to go ahead and substitute into my original problem. So I have the integral of sine of x over u, because that's what cosine x is now, and then times du, negative du, over sine of x. And so here we go. This is what we needed. We needed the sine of x to cancel. Okay, so we go ahead and do that. And we've got our integral now of 1 over u du, and it's negative on the outside. So 1 over u, what function gives us a derivative of 1 over u or 1 over x? It's natural log. So this becomes negative the natural log times the absolute value of u plus c. Okay, that's the integral. And we go ahead and write this as negative ln of our u value, which is cosine of x. Notice how it's absolute value there, and we need that. Okay, whatever goes into natural log has to be positive. So that's how we take the integral of tan x. So the integral of tan of x, it's a new rule, negative ln times the absolute negative ln of the absolute value of cosine of x plus c. So that's a rule that you're going to want to know. Okay, so let's look at cotangent. It's going to be very similar. Okay, the only thing we have to do is really switch what happens with our original function. Okay, so cotangent of x dx. Okay, so just like the previous example, why don't we rewrite that as cosine of x over sine of x? Okay, and that's dx. So now I'm going to let I'm going to stick with the denominator. U is going to equal sine of x. And that means du equals cosine of x dx. Okay, so that means solving for dx, we get du over cosine of x. And that is going to equal dx. Done with the u part, now we substitute. So now we have the integral of cosine of x over u times du over cosine of x. That is what dx equals. So I've substituted. Now look, cancel. Well, it becomes 1. And now you're integrating just 1 over u du. There's no negative there. So we have the natural log of the absolute value of u plus c, which ends up being ln of sine of x plus c, and that has to be absolute value. So there's cotangent. So now you got the rule. The integral of cotangent is equal to the natural log of the absolute value of sine x plus c. So I've got one more example to show you. And it is integral of secant x. Dr. Reedy, you can say hi.
Hey.
Hey.
How do you
All right. So we got one more to show you. Now this one is not intuitive. I love the explanation of this. Okay. So if you use substitution at first, it's not going to work. So we're actually going to take secant of x and multiply it by secant x plus tan x over secant x plus tan x. And it's by dx. Okay. Essentially, we multiply by 1. Okay, that's all we did. When we simplify that, you get the integral of secant squared x plus secant x tan x over secant x plus tan x. Now, you're probably not going to be able to figure this out. Well, multiply it like that. I'm just basically doing this to show you the rule. Okay, this is just another property. Okay, just like a power rule. So now we're going to let u equal the denominator. So in all three of these instances, the denominator was our u value, okay? And that's not by accident. So du equals the derivative of secant x is secant x tan x, and the derivative of tan x is, I'm going to run a space, secant squared x, and that's dx, okay? So we go back into here, and we have secant squared x plus secant x tan x all over u. And notice what du is. Du is equal to that numerator. So you're going to have du. Remember, if we solve for dx here, we get du over that big mess up here, secant x plus secant x tan x. Okay, this becomes 1, and you get 1 over u, and we're integrating. Okay, get my picture there, 1 over u du. Okay, so this now is equal to the natural log of the absolute value of secant x plus tangent of x plus c. That's a property. The integral of secant x is ln of this. It's a property. I'm not expecting you to remember, oh, you should just multiply by that. It's not intuitive. I'm just showing you this is another rule. So if you have any questions or comments about these three integrals, okay, you can go ahead and type them below, and we'll see you next time.